Okay. Well, thank you. Really happy to be invited to participate with this international event to share information. I work for the U.S. Fish and Wildlife Service. I manage our coastal program in California for the San Francisco Bay and outer coast of California. I've been doing some process-based restoration throughout the Sierra and the coastal areas, as well as parts of the Cascades, since around 2014. And when I think about process-based restoration for our program with the U.S. Fish and Wildlife Service, it's really, for me, it's really the science of how do we get nature to do more of a bigger share of the restoration work, because that's going to really allow our program to scale up and allow us to do more work to restore sensitive species for the Fish and Wildlife Service. So I'm going to go through one case study at Doty Ravine Creek in the foothills of the Sierra, and then also talk about some lessons we're learning from beaver, and then a little bit about how we're scaling up our efforts in California and Southern Oregon as well. So this was Doty Ravine Creek. When I was first invited out to look at this site, it was pretty typical. I got to know the landowner. They invited me out to look at some bank erosion issues along the creek caused by cattle. And with this particular project, before, well, the landowner was a land trust at the time, but they were running livestock on this property. And they were interested in just doing a bank stabilization. And this is a great example of how, if you don't, you can set goals from the beginning and end up with very different endpoints. And this was around the time when I was learning more about process-based restoration approaches. And I thought, well, okay, what are the source problems at this site? One of which was they were killing and trapping the beaver along here and along this incised channel. And so we simply just, over about 2 years, I convinced them to stop trapping the beaver, and we started post-assisting some of those beaver dams. And, pretty quickly, the floodplain reconnected. And after some time, I realized that, the bank erosion issue really wasn't a big deal to even the landowner. They just saw it as a problem because people just assume bank erosion is an issue. And of course, at that site, there was no nuclear plant on the bank. I love Colin's mention of that. But, that's usually the main point I'm looking for. If there's a bank erosion issue, what infrastructure do I need to protect along there? Otherwise, we're looking for what other problems there are to address within that system. And then what processes there are to potentially restore. And when I'm talking about processes, three of the major processes I want to restore: primary productivity within the valley, within the stream corridor, deposition and erosional processes, and channel migration and anabranching. These are really easy processes, not only to think about within setting goals of a restoration project, but also to monitor with, say, Google Earth, with publicly available data for your project. And then when thinking about a process-based restoration project, it's important that we all remember that we're not really talking about anything new. Other than a few components, we still need to do the important things of addressing source problems, infrastructure. What are the disconnections upstream of the site that may be holding sediment supply or wood supply, or obviously fish passage issues, and then downstream base controls. Jared mentioned this, and really defining that base control with common approaches, such as just looking at a longitudinal profile, as Paul mentioned, using the LiDAR to really assess your lower valley base controls. Land management issues. This is more of the social part of the project, but these are the two basic issues that we need to really look at up front within the context of the geomorphology. So important to remember that we're still approaching these projects the same that we would, that we have been for decades. And the new kind of component we're adding in, I think, is this idea of structurally starved systems. So once you start to address some of these source problems, we do see natural recovery within many of our streams. We start to see these riparian areas grow back. But we also, in the case on the left, that's a coastal stream, and on the right, that's a meadow in the Sierra. And in both cases, they have a lot of material, a lot of productivity, but the stream channel itself is lacking structure. And that's where these beaver dam analog or low-tech PBR approaches, the kind of systems that we can really get in. We have the material there, and we can really start to work and recover, get even more recovery out of these systems. And so with low-tech PBR, BDAs, PALs, which are post-assisted log structures, there's a lot of terms out there, but we're really just mimicking wood process with these. And this interesting study from a few years back, that wood occupying 2% of the stream bed provides 50% of the flow resistance. So there's a huge potential to really use this material to get that stream evolution and recovery going within these systems. And and it's important too to just think about it, basically getting the material into the system. Don't overthink. There's some good manuals on approaches and structures, but find a site. Don't be afraid to experiment. This is an example here of placing a conifer that was along the edge of a meadow, and then packing it as a dam, and then placing posts within those conifer, within that conifer dam. And then here's another example where we simply loaded wood upstream, not knowing whether it would stay in place or not. And it didn't. It went down to our lower BDA base control area, and that's fine. So we're really working with dynamism within these systems, and looking at how the system is depositing and evolving, and kind of working with those processes. And each site's going to be a little different. And we're doing that within the context of the channel evolution model that Colin and Brian, of course, in their 2014 paper, and Colin described earlier. And when I'm thinking about how to apply beaver dam analog approaches within stream, and thinking about the channel evolution model, I'm thinking about two general strategies, and beaver do this. And number one, when they're looking at a site, well, I guess I don't know exactly what they're thinking, but from observation, they're looking at where are these low-hanging fruit areas. We're starting to call them switches. I think in the paper they're referred to as short circuits. These are the kind of, these are the cool locations, the sexy locations that you're going to get a lot of habitat change quickly, because the differential between the stream bed and the floodplain is in most cases I'm seeing like less than 5 feet, where you can really reactivate a floodplain surface within a reasonable time frame with these approaches. And on the top picture you can see an avulsion occurring as a result of a BDA we installed. And then below, we're just kind of widening that stream channel. And then the other, the other direction is simply just working with recovery of the system. And so, yeah, I'm trying to get my slide, but yeah, there we go. So really, working with this other channel recovery, going from stage 5, 6 up through stage 8. And we're simply just, a lot of times we're just raising the water table within this system to get more productivity within that, within that channel and connectivity. And you're observing how that system's changing and working with those different processes. So, there's various reasons why we're taking a process-based approach. We're seeing increased productivity within these systems of many different species, birds, amphibians, anadromous fish. And then when we're using the low-tech approach, it does provide an opportunity to avoid larger disturbance, which has the benefit of reducing risks from compaction and all of the risks that go along with larger scale construction. Perhaps on the site you already have sensitive species habitat, which is very common in our Sierra meadows, where we already have yellow-legged frog or willow flycatchers within these narrow incised corridors. And then, of course, disturbance to Native American cultural resources, and then secondary benefits. They're lower cost in many cases, easier regulatory pathways, and then reduced greenhouse gas emissions where we can implement these approaches. And as Jared mentioned, we did put together this paper on developing design criteria, or in other words, defining metrics, quantitative metrics for what we're going to do and how we're going to accomplish it. And with this paper, we didn't really invent anything new. It was more just a matter of digging this information out of the literature and bringing it to the design table up front, so that there's already such detailed design criteria for channel construction that a lot of times the process-based approaches can get kind of sidelined because people thought of them, for years. I got the response that, well, it's more of a kind of a philosophy, but there are real design metrics that we can use of space, of using natural energy, of using natural material, doing work adaptively over time that can provide people a better concept and communicate these of these projects up front in the design process. And this is a graph from a paper by Matt Condolf from a number of years back on determining what areas are appropriate for allowing the river to heal itself. And I think that this is something a good conceptual model to keep in mind when you're looking at an area is like, as you're in these more urban areas, obviously you have less of an opportunity. And then as you're in systems with lower energy or lack of a sediment supply, you would have less of an opportunity to apply some of these approaches. So, interesting paper and conceptual model for considering what range of process you can actually use for a project. So, looking at the space criteria, this is Doty Ravine. As Jared described earlier, we started by doing some levee breaching, and then also installing beaver dam analogs. And within this floodplain, we restored about 57 acres. I guess I would add some additional information here that in my experience, it's some of the lowest root are these semi-confined floodplains where perhaps you have only one landowner to deal with, and so working within these semi-confined floodplains provide some easier opportunities, and then also we find it's easier to work with livestock operations, obviously, than some of the more intense agricultural operations where we can still work with cattle within these systems actually, and have some success as well. So that was opening up the lateral space. Also important, again, to remember to consider the longitudinal issues, such as the lower base controls and upper valley infrastructure. In many of our meadows, we have these massive road networks that disconnect not only fish passage, but also movement of sediment and wood from the watershed down into the valley bottom. And the more you can address these source problems, the faster your system is going to recover when you start adding wood structure or these beaver dam analog structures. And of course, doing this, considering this infrastructure within the within the context of the geomorphology, so that you can prioritize what infrastructure areas where you're going to get the best bang for the buck in terms of process restoration to address a lot of these road issues. Energy, using energy as we're developing a project with BDAs, we're bringing the water table up, we're taking solar energy and productivity in that system and getting that vegetation going again. And then also flood pulse energy. Floods are going to bring in sediment supply, get that sediment not only deposited in the channel, but out onto the floodplain, building new channels. And then biological energy as well, of course, beaver, and there's a whole range of biological energy from otters to worms and many other wildlife species to consider. But also when I'm thinking about energy and going back to that Condolf figure, I've noticed it is a little more challenging when we're in spring systems. On the left, that's a fen system, so we don't have a whole lot of energy or sediment supply in that system. So it's really it's a great opportunity for beaver if you can work with beaver. In that particular one, we didn't have beaver, so we're managing those structures, and we can get a lot of productivity, but we're not getting a lot of sediment coming in. As opposed to the photo on the right, which was at Doty Ravine, we have a strong sediment supply. We have a strong flood pulses coming through that system. Fortunately, we also had beaver there, but that's the kind of system where even though if we wouldn't have had beaver, I would have been more confident about, getting structures, building depositional zones, I should say, on a site like that. And so thinking about, the type of stream energy that you're working in is important. Materials, we're just using natural materials from the site, just like beaver do. In some cases, we're hauling them in maybe fairly close. In this case, we were hauling in some conifer that was part of a fuels treatment project nearby, actually working with the Mountain Maidu on some of their fuels treatment that the tribe was doing around their meadow. And but that's a good opportunity to use material that otherwise, typically we're burning. So you're using an otherwise waste product for your stream project. And then on the left, we're just reinforcing an existing beaver dam with some posts that actually previously was a post line that we weaved, and then the beaver occupied it and started building their dams, and then we came back in and reinforced their dams. So kind of this adaptive structure over time. And then using material, again, we don't want to overstabilize. Here we're using a post-assisted kind of willow weave structure to blast out a bank and recruit wood into the channel to add more structure. And so, again, you're using the materials on site, or you're rearranging, you're helping nature kind of rearrange those materials on site. And then, doing this over time is really the key to this, because you're doing it adaptively and you're learning how nature is working at your site. and that's the way you're really going to figure out how to design it. You don't have a blueprint up front for exactly what it's going to look like. So because you're inviting nature to the design table, you're having to do this adaptive process. And in the top picture, year one, we're breaching the levee in that photo. And then you can see we installed a beaver dam analog. And then the first year, the channel migrated around the beaver dam analog. And then year two, we continued to construct that BDA following that channel migration. And then we have connectivity to the floodplain. And you start to see channel formation on the floodplain. And then once we connect these incised channels to the floodplain, we're also still mimicking beaver. Where you have these single thread kind of stage one channels on the floodplain, and then we're spreading those out just like beaver do. And that's what you're seeing in the lower photo there. One of our meadow sites, after we reactivated the floodplain, we're adding more wood and small structure and continue to spread that water out within that type of system. And, it's important to remember it's not about the structure that you're building. It's about the process that it's invoking within the system. And this was a channel that, developed as a result of a BDA that we installed. And you can see year one, a lot of geomorphic work. We see a lot of deposition occurring on the floodplain, where it's a lot of times we'll see this kind of signal ahead of the year before it actually builds the channel. You start to see a lot of deposition in that zone, and then all of a sudden by year three we see channel formation that goes through the base flow period and all the productivity that comes along with that. So again, the importance of working over time with when you're using these structures, and this just shows a time frame at Doty Ravine from 2012. We were doing some heavier construction. There was a wetland constructed there that was like 0.1 hectare of area, and it cost like almost $200,000 to build. And then there was a tree planting effort, but we really didn't start doing the BDA work until 2016. And then you start to see the anabranching in dark there on the bar graph develop on the site as most of the acreage became a series of anabranching channels. And then, one of the pushbacks we get with this approach is that it's adaptive, or quote unquote requires maintenance. But I've done a number of construction projects in the past, and they require maintenance as well. It just may not be stated up front, but they often do. And in fact, we're going back to a number of our constructed projects and doing more process-based restoration, adding more wood, adding more structure to those sites to continue to evolve them. This is an example of a pond and plug project in the Sierra that routed and is head cutting. And so, just because a project is constructed doesn't necessarily mean it does not require maintenance or long-term management. In this case, I just wanted to show that, when you're doing, you have the stage 0 kind of is one of your goals with a project, and you're using beaver dam analogs. The way beaver do that, they're not going to reconnect everywhere at once necessarily. So in this case, in year 1 on Doty Ravine, this is a LiDAR shot of this little 60-acre semi-confined floodplain. And you see in year 1, there was a narrow corridor of connectivity in blue. And then and the beaver had these, they found these sweet spots within that system where it was relatively close to the channel depth was relatively shallow, close to the floodplain surface. And and they, the first year I could tell at one particular location, the beaver dam, it almost looked like this infinity pool. They rose the water table up early in the summer, and just productivity going on that floodplain before it was flooded. And it's really interesting. It's almost like, just they knew to like get the roughness value going before reconnecting. And then year 2, I have delineated on there roughly the 15-acre area that they reconnected in year 2. And then year 3, they connected another 30 acres. And year 4, they were connecting sections of this property annually. So that's another part of this approach to consider, is that there's a lot going on. There's a lot of different channel state all over the place at once. Stage 0, stage 8, stage 2. So it can seem kind of chaotic, but it's really just nature's way of recovering a site like this. So just some quick lessons about working with beaver. We learned from many sites that channel fill and construction isn't always necessary. The beaver can do it. We're replicating that at sites where we don't have beaver now, up in the Sierra at a few meadows. And that, we were over-stabilizing a lot of areas, using a lot of large wood and rock to over-stabilize areas that we didn't need to. Right now, I wanted to see if Amy could show us this video and hit play. This is a BDA construction, and we'll super fast forward here. So you see they're using soil, using conifer, using all kinds of vegetation from around, and then coming in with some fire salvage logs, and just bringing up the water table of this. This is within an inset. This is kind of the objective here, is going from like a stage 6 to a stage 8 channel. And you can pause it. That's good. Thank you. And so what, they're, and so they're encouraging the productivity on that inset floodplain that you see there. They're going to encourage channel anabranching onto that floodplain, perhaps even encourage more channel meander to occur, and more bank erosion to occur on that outside bank. And you can see they're using a lot of soil too. They're using a lot of the materials that beaver use. And I can't stress enough that, building these structures is a great volunteer opportunity, but if you really want a lot of work done, you need to find good crews. You need to find, it's a lot of heavy lifting. It's a lot of hard work. This crew I hire, I've been working with them. Jared and I actually trained a lot of them up early on years ago. And they'll camp out at these sites for like 2 or 3 weeks and work on these sites. And if you can imagine a crew like this working on a site for like 3 weeks and coming back the next year working for 2 weeks, coming back the next year working for another 2 weeks, they can do multiple miles of stream and really have an influence on the recovery and on the way that channel evolves. And they really learn. They're not just good with their hands, but they have a good eye for looking at how these streams are trying to recover, and setting objectives. It's a great opportunity for people. It's a great, just a great opportunity to engage a lot of people in the restoration workforce, for sure. And so just this interesting concept of reactivating these floodplains that without filling the channel. You can see this in this Doty Ravine site. You see the floodplain is flooded, and you can pretty clearly see the incised channel along there. And then when we go to summertime, same general area, but you can see the incised channel has kind of disappeared. And we call this like basically filling the channel with sunlight and just getting the productivity going so much that, the roughness factor of the incised channel is just crazy. It's just filled with, cattails and tules and willow. And then, there's fully activated floodplain during base flow as well. And here's just to, again, giving some of the depths of the existing incised channel. In some areas it's almost 7-8 feet. So, a lot of times I'll go out to a site and landowners or partners to the deepest location of the incision. Well, I want to see the shallowest location as well. That's an important location to look for, not just your deepest areas, but your shallowest areas. So, this issue of valley base control is so critical, really characterizing why is the base control an issue on your site. And maybe it's something you can address. If it is, it's something you must really focus on addressing. If you can't, then you're having to work with these structures and work with, depositional process within an alluvial stream and get enough of a base control that you can start building it back up within your site. But when you have an incised channel in a reactivated floodplain, you're going to have small head cutting in a lot of locations, and that's from my observation, that's been okay, because we're getting productivity on the floodplain. We're getting a lot of vegetation, a ton of roughness on the floodplain, a lot of productivity in this incised channel. All of that productivity is, in vegetation is the reason we don't need rock and we don't need to stabilize it, because it's able to stabilize itself. And you can see that in the an earlier head cut that just, basically got filled in with vegetation. So yeah, just, that up front, we can make some costly mistakes too with projects, going down pathways that may be more costly, or, where nature may have been able to do the work. And so, really trying to do that analysis up front to make sure that, is there a possibility if I can get nature to do this work for me? We would have had to have filled thousands of cubic yards of channel here, probably required large grade control structure for some of that area. And then originally we had a plan for a new channel construction design. This was back in 2014 when I first started this project, that, what would have been involved in that in terms of cost and disturbance to the existing channel, which actually is critical habitat for steelhead. And then, as Jared was mentioning earlier, thinking about the carbon inputs to the site, sequestration of the site versus emissions of the site. And as you start bringing all of these materials that in some sites, you may not have to. So, consider that within your within your design, because it could mean a difference of a magnitude in cost and in carbon emissions for the project. So just a mention of a couple tools and groups. California PBR Network. We meet online virtually every couple months, and just put the website up there if you'd like to visit and just meet folks on that meeting. Certainly a good opportunity to share information on PBR. And then the Riverscapes Consortium, folks out of Utah, they've been doing a lot of PBR work for years, and they've got a lot of great tools available there as well. I'm just going to flip through some other tools. As Paul mentioned, using the LiDAR, he's going to go into much more detail on this, but we use it for really identifying this key infrastructure within the system. These detrended elevation rasters are really helpful. In some cases, the Forest Service in the Sierra is using these to identify hidden meadows. They've been disconnected for so long by infrastructure that we're not even aware that they're potential meadow spaces anymore. Give me a minute here. I didn't realize I had all of these nations with this. Sorry. So one other modeling exercise we've done is in the Sprague River in Oregon. This is in southern Oregon. It flows into the Upper Klamath Lake. It's where we've invested a lot of restoration dollars from the U.S. Fish and Wildlife Service to restore endangered suckers within this river system. And we're trying to bring together these metrics of space, energy, materials, and time into a river restoration for our agency. And I'll kind of zoom in on what I'm talking about here with this model, where we, up front, we're identifying the existing connectivity within the system, total valley process space available within that river valley, and then the area that we think we could re-wet during summer base flow, that we could turn into this river wetland corridor stage 0 area. And then identifying what are the spaces within those areas that are disconnected by infrastructure versus those that are simply disconnected by incision, pink being the infrastructure areas that are causing the disconnectivities. And then overlaying the beaver restoration assessment tool, which guides us on where best to place beaver dam analogs within the system, which could be a whole nother presentation in itself. And then over that, the infrastructure, the priority infrastructure within those disconnected areas. So this gives commissioners within this river basin a whole set of ways to prioritize what infrastructure to modify, where to work with beaver dam analogs, where to prioritize projects within this system based on process-based restoration objectives. And final topic I want to bring up is PBR and fire. Some folks in California have done some really great research on this. Emily Fairfax did this paper on Smokey the Beaver, recent publication, but simply the idea that, re-wetting more of the stream system can influence wildfire and not only provide habitat, but potentially provide areas during wildfire events for perhaps for fire crews to initiate fire breaks from, and this idea of we're not just reducing fuels within the landscape, but we're making the landscape wetter. So it's just another tool for wildfire uh, management potentially, and we're now really focusing on working with fuels crews throughout Sonoma County and near the coast, and also throughout the Sierra, and trying to integrate process-based restoration and getting that material from fuels projects down into the stream. And that's really provided another land management tool because, you know, it can be challenging finding landowners or stakeholders that are interested in our species goals. But you know, wildfire crosses all boundaries and really is something that people can relate to and certainly are interested in for for their properties. And it's just a great opportunity to really efficiently scale up process-based restoration within many of these western streams. So that's all I have. Thank you.